So let's get started talking about ag water. The pre-harvest water part of the rule, which is subpart E, changed dramatically in May of 2024 when they published the new rule. And Jen is going to put that link in the chat room also for you. All the information and fact sheets by FDA are in that on that URL code or the QR code that you can get from them. There's also a tool that you can use to see if you need to comply. The major revisions of the pre-harvest water is the fact that less reliance on water testing, more reliance on the grower being able to identify and understand their water system, how it works, and able to explain that to an inspector during a visit. So the water testing has really been de-emphasized in this compared to what it was in the 2015 version of the rule. I did want to mention something about harvest and post-harvest water. The harvest post-harvest water version is now in effect. The last one is in January or 26th of 2025 that goes into effect. What does this mean? It means for post-harvest and post-harvest water, you would need to pull 4 samples during the season and to be tested for generic E. coli. And I'll talk more about that after a while. And they have to come back as non-detectable generic E. coli. If you have 4 samples that come back with non-detectable generic E. coli, then the following year you can pull 1 sample. And as long as that sample continues to show non-detectable generic E. coli, then you'll be fine. You won't have to go back to the testing 4. However, if that one comes back with generic E. coli, then you would need to go back to testing 4 times. So that's really not a change from the harvest and post-harvest. That's the way it was from the very beginning. So let's talk about pre-harvest ag water. The new rule goes into effect this year for the largest operations over 500,000 in April. Then the next side, the 250 to 500 is next year, and the small ones is 2027. So there is time, and this is when you need to start complying. You do not need to start complying before this, okay? So what's agricultural water? And if those of you taking the PSA training have seen some of these slides before, it's water that used in covered activities, such as growing on covered produce, such as crops that are covered by the rule. And there's a list of those, which we'll talk about in a minute. It's tended to or likely to contact the harvestable part of the crop or food contact surfaces that crop would come in contact with. So that's agricultural water by definition. Covered produce means that are subject to the produce rule, and it's the harvestable part of the crop or the harvested part. And there is a list on 112.2A of the crops that are not covered. And for those who have looked at that, you'll notice there are things that you would think should be covered but are not. The big thing there is that FDA has determined these crops go through a heat process that would kill a pathogen. And that's what their definition comes down to. So let me give you a couple examples. Here is romaine lettuce grown without beds, for instance, overhead irrigation. Lettuce is covered, so that would be the crop. The practice is growing the crop and how the water is applied overhead. So in this case, it would be agricultural water, but because it's touching the harvestable part of the crop. Now, if that would have been drip instead of overhead, then it would not be considered agricultural water. Here's another example with carrots where this drip irrigation is being used along the beds. And in this case, the water is agricultural water because the drip water would be touching the harvestable part of the crop, the bottom of the carrots. If for some reason you would be harvesting just the tops, it would not be considered agricultural water because a drip irrigation would not be touching that part of the crop. I would say if you have any questions, please put them in the chat, and Meredith and Jen are checking that for questions. Another example, this is avocados, which are a covered crop, and on the packing line. Would this be agricultural water? Yes, because again, avocados are covered. They're going to go through the packing line, so that is going to be touching the crop. So it would be considered agricultural water. So what are the concerns with pre-harvest water? Obviously, we know there are many factors that will affect the quality of the water. There's many uses for the water, which we'll go into in more in detail. And human pathogens can be introduced into the water contaminated. When I was working in Central America, one of the issues was we were using water from a canal, and we were having problems because of pathogens. We ended up switching our water source, and it took care of the issue. So you have to think about where that water is coming from and what's the possibility of pathogens being present. And how water is used obviously can impact it. Irrigation, fertigation. Some people don't think about sprays, but that spray, again, if there's something there, it's a harvestable part of the crop, then that could be considered agricultural water. An example, for instance, blueberries, even just with flowers, that is considered a harvestable part of the crop. So it would be considered agricultural water. So how evaluating the risk can related to how that water is used or where it's coming from. For instance, the quality of the pre-harvest water, is it a public water supply, which most people wouldn't be using because of availability and cost? Groundwater, in other words, wells, or surface water, whether it's a stream, a pond, a lake. How often you're testing it, the frequency and sampling, if you're doing that. The method, whether that water is going to touch the harvestable part of the crop or not, and when it's applied. The closer you are to harvest, the more possibility there is of contamination. So you may be putting on, for instance, water on strawberries overhead to set the strawberry plants, but not using the overhead after that. So that would be a non-issue. So when we look at sort of a continuum of the quality of the water and where there could be issues, public water supply obviously is the safest source because it's treated by the municipality that has it. Again, the expense is one issue why you probably are not using public water, especially for pre-harvest. Groundwater next, because generally if the wells are deep wells, meaning say 100 feet, and it's a good structure of the well, then it would be less of an issue. And the biggest one is, I usually say, surface water is the crapshoot. Because especially if it's a stream, a river, a big lake, you don't know what happened above you in that watershed, and there could be a contamination issue. We've had instances in New Jersey where a grower was using a river to irrigate out of. We were sampling that river, and there were some issues. He switched then to well water for all of his irrigation, and he had no problems after that. So you have to think about, especially in that case, where things come from. If you have a public source, again, it's treated, and the biggest issue may be from the point of where it comes on your property and what's the possibility of it getting contaminated. And do you have a backup plan if something happens? For instance, if there's a boil water advisory by the municipality, can you still use that water? Is that a possibility of contamination issue because of that boiled water advisory? So you have to think about, even if you're going to use public water, what are some of the problems you may have? For groundwater, the big thing there is, how is the well constructed? Is it sloped away from the casing? Is there a problem with a crack casing? Is there a problem because the seal on the top of the well is not set properly and there's a possibility of either rodents, for instance, getting in there? Is there a backflow device on the well? The one thing with backflow devices that we've run into is how do you check whether they're working or not? And this is a continual issue that well drillers are not even sure in some cases whether you can test the backflow and how it's working, but they should be evaluated each year if possible. And you can tell that somewhat by the pressure on one side of the backflow versus the other side if you have dials on there that you can read them. But making sure that that slopes away, the ground slopes away from that well casing is very important. What about surface water? Obviously, as I said, you need to know what's upstream for you. What are the problems that may be related to animals, for instance, in the watershed, and it may only be close by where you are. We've had instances where a small watershed where water quality was fine through most of the summer. However, towards the end of the summer, we had heavy rains and a lot of animal activity, and we had problems with pathogens in the water because of it. So those are some of the things you need to think about. And how you address issues for like runoff. If you have a pond, what's the possibility of runoff coming from fields or going into the pond? You need to think maybe about putting a berm or ditches around some of those water sources. And also about animals, what's the possibility of access of animals in the water source, even directly right in, for instance, into a pond where livestock is drinking or walking through there. The irrigation method can have a major impact. Obviously, overhead sprinklers are what we use a lot on some of our crops. It's a direct impact, a direct application method. Flood, which we do not use in the east, but they do in the west in some areas, especially on citrus. It's less of an issue than overhead because the water generally does not touch the harvestable part of the crop. However, you may have an issue with splashing if you're going through it for some reason. The least risk is drip or trickle, as long as, again, that water doesn't touch the harvestable part of the crop. Root crops are the exception to that. What about die-off? We do know that die-off helps reduce the pathogen level, whether it's desiccation because they're drying out. Ultraviolet light radiation helps a lot, especially in areas where there's high level of sunlight. This past summer was a good example in New Jersey with that, but in Southwest, Southern California, that's a main way that they can control pathogens. Temperature and humidity, lower humidity, higher temperatures can kill off pathogens that may be on the plant, and also starvation or competition. The pathogens we're talking about, whether it's E. coli, salmonella, they're really invaders on the plant. You do have microbes that are present, that are resident on those plants, and they can help control, to a certain extent, some of those pathogens. One issue we do have with some of our crops is that leaves may be curled down, which means that the pathogen underneath that leaf can be protected. For instance, a spinach with a curly leaf curled down that can be protected from there. Also, some pathogens may survive, and then when you get the right weather conditions, for instance, a lot of rain, then they may multiply on those plants. You will need to inspect your system. We'll get into what's required as far as inspections are concerned, but you need to think about where the possibility of contamination may be in your system. A good way to do that to help out is first map the whole system. Use an FSA map or Google Maps where you can draw right on there where all your mains are, whether underground mains, surface piping, lay flat, so you know where all of that is right on your map and how it's distributed through this system. And this inspection must take place once a year. And also keeping any debris or again, as much as possible, animals away from it. You'll notice on this picture here, this is a deadhead where the water is coming out. What happens if enough water comes out because you've shut down the system and the water's running out of there, you can get a pull of water, which will get up to the point where it will re-enter the pipe when you turn your system back on. Thus, you can be contaminating the water source. So you have to think things like that. Also, elbows, for instance, are great for leaking once you shut the system down. And again, how much water is going to collect around where that elbow is. So we have two different, under the new rule, we have two different inspections and assessments and need to take place. These are two separate things. They may sound similar. Some of the records from, for instance, the records for inspection should be included in your assessment, but they are really two different records, and they must be written records. For the agricultural water system, which is the first one you need to do, again, that's describing your whole water system. That's also true for pre-harvest, harvest, and post-harvest. And this is the only one that you're required for harvest and post-harvest, along with pre-harvest. So you describe what your system is. Again, the map, I think, is a good idea to help you cover that. You put on there where, if you have a pump house, for instance, you put that on there, where all your connectors are, wherever your irrigation goes, what type of system you're using, whether, again, you may have some overhead some places, you may have drip in other places. So you need to have that as your record. And that, again, that's before, right at the beginning of the season, you can do that.
Hey, Wes?
Yes.
There's no requirements for that having to be, computerized, or it can be a pen and paper, right? There's no specifics on what that needs to look like.
That's correct. It can It can be pen and paper. It does not be computerized at all. And it doesn't go anywhere. You keep that. Then when the inspector comes, you show them that record. So the inspection, again, source of the water. In some cases, you may have more than one source. It may be, some of it may be groundwater, some of it may be surface water. But again, where all your sources are, to the extent that's under your control, you don't have much control if it's a river or a stream, for instance, but how much of it's in your control. The degree of protection for each source. So if you have a pond, for instance, is it fenced off so animals can't get in it? What's the use of adjacent and nearby land? By definition, adjacent land by FDA is land that essentially contiguous with your property. It touches your property. What are they doing there? Is there animals, for instance, a feedlot next door, or a dairy operation? What's the possibility there could be contamination from those? Nearby land is a term that FDA says, well, it's land further away. There's not a clear definition by what they mean by nearby land. So the biggest thing is that adjacent acreage around you. And what's the likelihood of, again, that nearby or that adjacent land could introduce a problem to for food safety on your crops? So the key requirements for an assessment, and that's an inspection. Inspection takes place at the beginning of the season, needs to be done annually, must be written, must be signed off by, must be dated, signed off by a supervisor. Then you keep that record. So that's your inspection. That same information can be part of your assessment, but there is additional information that you need. Need to know, again, where your buildings are, where the equipment is related to the irrigation. And this can be done at the beginning of the season, must be done at least annually. And then also if there's any significant changes. For instance, if you switch from a well to a pond, that is a significant change. And so you need to make sure you note that. And as I said, it needs to be written, reviewed, and dated and signed by a supervisor. The assessment starts to get involved. And this is, again, this is new under this water provision. You have to have the evaluation of your location, nature of water source, which you're also doing for the inspection, type of distribution, degree of protection. All of that information you already have from your inspection. So you include that in the assessment. Also, you have to include agriculture, the water use practices, how are you irrigating? Again, is it drip? Is it overhead? Is it center pivot? Is it big guns? And for each water source. So they may be different depending where you are. Crop characteristics, we'll get into that in a minute. Any environmental conditions that may impact food safety and any other factors. So we'll get into those, especially those last three in more detail. So the assessment really is to identify and evaluate conditions that are reasonably likely to introduce hazards and to determine whether reasonably necessary to reduce the potential contamination. As I said at the beginning, there is an assessment builder tool that FDA has available. It's on that website, which the Jen put up at the beginning. I will tell you the tool is a challenge. You can do it online, or you actually can print out it and do it in person. My suggestion, if you're going to use it, I would print it out because you can see more detail as you print it out. But it is a challenge to use it as it's done right at the present time. And we've looked at it a couple of different times and have some questions about how it works. So let's talk a little bit about some of the characteristics and whether there's susceptibility or not. For instance, the location, nature of the source, obviously surface water, there's more problems. Municipal groundwater, there's less susceptibility. Type of distribution, again, open canals, laterals, lay flat can be more susceptible, especially, things like lay flat, things like aluminum pipe. You always have places where you're going to have leaks, which makes it more susceptible. Anything that's a closed system and maintained properly, again, less of a problem. The degree of protection, it's again, how that water source is protected. Is it used for recreation or not? If it's not, obviously, it's less susceptible. There was a situation in I believe it was Oregon a few years ago, or it may have been California, where they were using a pond for recreation, swimming, and also for irrigation for crops. And they had a problem with food safety, an outbreak. And they really traced it back to the use of that pond for recreation. What's the possibility of open access for animals? Again, if it is, then there's a greater possibility than if it's protected. The same thing, whether other animals or if there's housing around, possibility of leakage, for instance, from the septic system could be more of a concern. So those are some of the things you need to think about. What is more susceptible, what's less susceptible when you're doing your evaluation. When we talk about agricultural practices, again, how are you applying that water? Is it overhead that you're touching the foliar, or is it sprays? Again, subsurface drip, we use a lot of drip here now, less susceptible because there's less contact, possibility of contact. And the other thing is how close you are to harvest. Close to harvest, a greater chance that if there's a pathogen present, then it will be carried on to the harvestable part of the crop. Or if you're using early, like I mentioned about the strawberries, there's much less a possibility. This is two of the issues that it's going to be difficult for growers in their assessment, and they must be included. Crop characteristics. We're talking about adhesion, in other words, the pathogen sticking to the crop. Internalization, we're not talking about internalization where it's taken up by the plant. We're talking about, for instance, if it gets damaged, and what's the possibility of internalizing a pathogen. Excuse me. So rough texture such as muskmelons, greater chance that there will be adhesion. And there have been instances where that has caused problems for soil-borne or an outbreak. Largest surface areas like big leaves of a crop, thin epidermis layer, such as, for instance, basil, growing close to the ground is a greater chance that there may be a resident pathogen on the outside of that crop. Less of a problem if you have a smooth or waxy texture, say cabbage, which is very waxy, doesn't adhere as easy. Smaller surface area, tough epidermis, again, cauliflower, collards, or grown off the ground, such as steak tomatoes, for instance. They also want you to evaluate the possibility of environmental conditions. This is, to say the least, difficult. I should say the crop characteristics. They're talking about each crop that you are growing or irrigating. So it's just not one crop, it's all crops that you're growing. Environmental condition, this is the harder one that I think is they want to know whether the possibility of a freeze or a hailstorm. If you're growing very early in the spring, such as in South Jersey, you're planting in February outside using row cover, there's a possibility of a freeze. And that's the type of thing that they would like to see. Hail damage, I'm not sure how you would even say, yeah, it may be hail. Less sunlight, again, same issue. I don't know how you address that. But the biggest thing is pointing out if it's a spring crop, the possibility of a freeze, yes. During the summer, obviously, no. I would not, when you do your assessment and you write it up, again, as we've said in the past about other issues, do not do anything you are not going to do. Do not put something in your assessment that you think someone wants to hear. You put down what you do. Let the inspector look at the assessment and say whether it needs to be more complete or not. I think that's very critical for all growers to understand. So, what about water testing? Water testing has been, in some sense, put on the back burner. You can do water testing, and I also want to mention that if you have a third-party audit and they require monthly water testing or whatever they require, continue to do that because, again, that's part of your third-party audit. Understanding that that same information can be used for your assessment, but it is not required if you aren't already doing it. Also, water testing cannot be the only basis for your assessment. You must do those other things. You must write up those other parts that I just talked about. So it can be one part, but not all parts. Again, and we're talking about generic E. coli only. So once you do your assessment, what about the outcomes? Well, if the water's not safe and not a quality of sanitary value, you have to stop immediately using it. For instance, if you find out there's a septic break and gets into your water system, something like that, then you would stop using it and you need to take corrective actions before you use it for harvest, for pre-harvest use. And we'll get into what a corrective measure means in a moment. If you have adjacent or nearby land where there's a possibility of animal activity, biological soil amendments were applied, manure in other words, then it's a mitigation measure needs to be taken, but no later than the same growing season. So there's a little bit more leeway there on what you do. If there's other conditions you may find that may be a hazard, then again, it's a mitigation process, but it's as soon as practical and no later to the following growing season. So that gives you the rest of that season to be able to use that water, then make those changes you need to make over time. Or you test the water as part of your water assessment. Don't need to do that, but if you want to do that as your mitigation measure, you can do. And if you find no problems recently or no hazards, then it's a regular use the water system and you do the assessment annually. So what are corrective measures? Re-inspect the entire system under your control and make any steps or changes to correct that. And it may be something as you re-inspect the system and you have a broken pipe and you fix that. That's what you do. And you must make sure you note those. You have that information. Or you can treat the water system according to FSMA and PSR. Treating water for pre-harvest can be a tricky issue. At the present time, there is only one chemical that's approved going through an irrigation system that can be applied when you have a standing crop, and that is the Sanidate 12. That's just been approved in 2024 for that purpose. All the other ones that you could use, it cannot be applied to the crop. You can put it through your irrigation system, but it cannot be applied to the crop. So that's very important. There's only one product at the present time. So for mitigation measures, you have a lot of other options. Again, making repairs, which we already talked about. Increase the time for die-off from the last irrigation to harvest, or from harvest to end of storage, or anything else that will help with die-off or removal. Change your water application method. You may go from overhead to drip, for instance. Treating the water, which we'd mentioned above, and any other practices, as long as you have the scientific data to support those practices. So you have much more options when you're talking about mitigation. Again, I already talked about the fact that you can make the repairs, you re-inspect the system, and correct what the problem may be, like manure runoff, for instance. You put a berm around to keep it away. Making sure that there aren't any practices you're doing that are a problem as far as state or county regulations are concerned. And you're implementing practices to reduce hazards. And you need to confirm the repairs were effective. How you do that? That's a good question. In some cases, it's a matter of fixing that pipe that I mentioned, but it also may mean you need to take a water test to see if you do have a pathogen still present. But that is up to you to make those decisions. And when you have an inspection, then you need to be able to justify what you did. So treating the water can be, again, both used for corrective and mitigation measures. Can be chemical or non-chemical. In most cases, it's going to be chemical. You're reducing the possibility of food contact on food contact surfaces. And you need to keep records of any treatment you're doing, and you need to monitor it and have the records that you show when you started it, what you used, what the concentrations were, and you need to do that on a regular basis and have those records for the inspector. What about using the die-off or removal rate? To start with, you cannot use it for corrective measures. It can only be used for mitigation measures. And this is the die-off, again, between the last application of water and harvest, or from harvest to end of storage, or anything else that may reduce it. The die-off rate, according to FDA, right now, if it's longer than 4 days, in other words, 4 days back, then you're fine. If it's less than 4 days, so it's day 4, 3, 2, 1 before harvest, then you can use what is in the original rule, which was the 0.5 log reduction. But you must have the data. You have to have the data last time you irrigated and what the level of the pathogen was. In other words, what was the generic E. coli level at that point? And then calculate your 0.5 log reduction. My suggestion would be, if you are looking at the die-off rate, then you should be looking at stopping irrigation 4 days before you harvest. And in some crops, that's very difficult because you're harvesting and irrigating at the same time. So think about whether the die-off rate would work for you or not. You do need to do a reassessment each year and go through again and anytime they may make changes, as I mentioned before. Again, looking at the water system, the practices you use, the crops for each crop again. So if you're growing 20 different crops, you have to think about, can I group some of those crops together? And am I using the same practices for those crops? The environmental conditions, and then anything else you may be doing. And anytime they make a change, a major change, then you need to do that reassessment. And again, each time it needs to be written, whether it's a corrective action or a mitigation practice. Those are the basic things related to the new rule. It is easier in some cases because you do not need to do all of the water testing that was in the proposed rule. Before, for those who had taken the PSA, if you remember, if you were going to use surface water, you would have to pull 20 samples over a 4-year period. If you were going to use wells, then you would be pulling 5 samples the first year and 1 sample every year after that. So this is a little bit less costly in the sense of water testing. It's more time, I think, than it would be the other way. But I think this is overall is better than what the original proposal was. So let's talk about some other things that may happen. You have a broken emitter. They happen all the time on drip. We know that. So what does that mean? Well, if you go, you find it, you fix it, it's not a big deal. You're thinking about the risk. What's the possibility that there was water there that contaminated the crop? And that's what you have to continually think about. Human mistakes, again, someone use untreated surface water, or they forget to shut the pump off and the field's flooded. Again, you have to assess whether those are critical issues or not. And again, all this falls back on the grower to make those assessments. As far as flooding, and it's true flooding, meaning it's flooding from a lake, a pond, a stream, what impact does that have on your crop? You'll notice on this picture here, those are tomatoes. And there's obviously some flood water that touched the tomatoes. In that case, it's considered an adulterated food and cannot be consumed. So tomatoes would have to be destroyed in that case. It cannot go into commerce. There are some exceptions, which is important that you think about. One exception is if you sample 4 times during the season, as you need to do for your harvest and post-harvest water, and you have no detectable generic E. coli, then and you have the data to show that you can use that as your exception. And then the second year would be 1 sample every year after that, as long as you have no generic E. coli. This may be the best thing for growers who have third-party audits, because it may already be needing to do this. The other thing is if the public water system, again, if you have the documentation from the municipality, the certificate of compliance related to generic E. coli, or if you treat the water, those are your exemptions that can apply. You must have records supporting the exemption. So why are we using generic E. coli? It's the best indicator we have at the present time for a pathogen. It's an indicator of fecal material, not an indicator of true pathogens. There may be pathogens present and you have a low level of generic E. coli, but that's the best thing we have right now. And to be honest, it's one of the cheaper tests that you could have. Where do you go for testing? Our recommendation is you get a testing lab and they do the testing for you. They pull the samples. That way you don't mess them up. It's easy to mess up samples. I do it all the time when I'm sampling, just because I'm not paying attention or I'm talking to someone or I'm not waiting long enough. So our recommendation is that you get a lab that can do it for you. Jen is going to put in the chat the link to our list. We have gone and gotten all the labs in New Jersey and what tests they do and where they're located. So you can go there and look up what your closest lab would be. There are many different tests could use, but you have to make sure it's a test that is approved for use. And again, those have that. There are some that are have a CFU, which is a colony forming unit number, or a most MPN, which is the most probable number. Those are acceptable tests as long as they have the data. Again, for water, you're talking about a presence or absence of a generic E. coli. So in that case, it's much easier. But if there is some present, then you need to know how much is present. What about record keeping? You need to keep the records, again, of the inspection that you do each year. You have to keep records of the assessment that you do each year, and any supporting documents you may need for that or for an exception. If you're doing water testing, again, you need to have the information from the lab. You need to have the criteria they use for sampling, the procedures they use, if they're using something other than the EPA method 1603, which is the one that FDA had preferred originally. If you have getting the public water, then you need to get the annual documentation from them. And you have to, with your assessment, you have to, again, the documentation measures you used, any time intervals as far as die-off, when you stopped irrigation, when you harvested, any other methods you may have used, anything you've done as far as treatment, and you have to have the monitoring records for that. So we have a couple examples, or 3 examples here as we get towards the end. And I'd like to have someone chime in on this. This is, again, apples. There's apples on the tree, and pesticide application. Is this agricultural water? Someone just want to chime in? Bruce, you're good at these things.
Oh. Yes.
Yes. Yes, it is, because you have, again, the fruit present, you're spraying. Even if it was just flowers, it would be agricultural water, because the FDA considers that as a harvestable part of the crop. What about this one? You've got white potatoes, overhead irrigation. You have an activity which is growing the potatoes. You have a system where water is touching the plants. Is this agricultural water?
No,
Why?
because the water doesn't directly touch the potatoes.
No, the real thing here is potatoes aren't covered under the rule,
Yeah.
because you don't eat raw potatoes. Normally don't eat raw potatoes, I should say. So and that's true of sweet potatoes also, are not covered under the rule. So that's why you have to think about essentially what the crop is, whether it's covered or not, and what the irrigation system is. Are the 2 things you really need to think about. Here's the last one. This is head lettuce grown in a greenhouse, and it's being marketed in a clamshell with the roots on. Is that agricultural water?
Eric says yes in the chat.
Okay. Yes, it is, because again, the root is on that plant, and it's been in the water, and there isn't anything when you put it in that clamshell, you're not going to dry out those roots completely. There's going to be water there. If you were cutting that plant off, then no, it wouldn't necessarily be agricultural water. Or if you're using something that water is sprayed just on the roots and the plant is cut off, it would not be agricultural water. So again, you have to think about where that water is touching and the crop you're growing. So again, it's sort of as a conclusion, contaminated agricultural water is implemented in just not in a few, in many outbreaks in reality. You need to inspect the system. The inspection is one thing, assessment is a separate thing. You must do both of them. If the water doesn't touch the harvestable part of the crop, then it's not agricultural water by definition. That's also something you need to think about. And anything you can do to extend the time from that last irrigation to harvest, the better off you are. And you can treat the water, but you have to think about what chemical you're using. And remember, the label is the law with all these chemicals. Also, you need to have all the records, including any water testing you're doing, must have those records. Any questions?